Let's take a look at number 7 from the review. So let's read the problem. In the cube below, we are looking to find AC in terms of the side length, and then find the acute angle formed by diagonals AC and BD. And so let's start by finding AC. So let me just zoom in here on our diagram and figure out what we're trying to find. Well, we're trying to find this length here. We don't know a lot about it, so we need to pull in some extra information. What I need to do in order to start this problem is draw the diagonal across the bottom of the cube. So now I have a right triangle right here. So let's see what I can figure out. Well, I know that this side length, let's call it S, is the same as this side length S. I know that I have an isosceles right triangle, or a 45, 45, 90. So if these side lengths are S, I know that this side length must be S root 2. And I know this length must be S. Well, I have two sides of a right triangle, so all I need to do is the Pythagorean theorem. So let me get a little bit of space here. I know that S squared plus S root 2 squared equals, let's call it C squared. So this will be S squared plus 2S squared equals C squared, which once I simplify, I will get 3S squared equals C squared. So C equals root 3S. So that's the first part of my problem. I can either write my answer as S root 3 or root 3 times S. The next part here is a little bit harder to visualize, so I'm going to erase the markings we had from before and just kind of start from scratch. So the next part they want us to do is they want us to find the measure of this angle here. Well, if I draw BD, I create two sets of acute angles and a set of obtuse angles. So what we're trying to find are the measure of these angles here. Well, in order to do that, I have to go back to where we started on the first half. Using this diagonal here, I have a right triangle. I can find this angle in here, ACB. That angle can be found using right triangle trig. Let's take a look. We could say the tangent of that angle BCA equals S over S root 2. Or if I wanted, I could rewrite that as S root 2 over 2S, which is the same as root 2 over 2. Using my calculator, I found the angle whose tangent is root 2 over 2 to be 35.26 degrees. So let's see where that gets us. I know that I have, let's use a different highlighter color here, an isosceles triangle where I know the base angle to be 35.26. So this angle here is 35.26, and this angle here is 35.26. Add them together, and I get 70.52. I subtract that from 180, and I get 109.47 degrees. That represents the measure of the top angle of my hypotenuse right here. That angle is supplementary to the angles we care about. So the measure of the acute angles formed by diagonals AC and BD are the supplement of 109.47 or 70.52 degrees. And we're done.